As was mentioned previously, this is the second in our series of talks on learning WhizzML and using WhizzML in kind of the wild here. My name is Charles Parker. I'm usually kind of behind the scenes at BigML, working on the back end, and today I'm just gonna we're just going to walk you through some of the basic parts of WhizzML, kind of take a little surface dive into the language, talk about some of the features of the language, how it works, what coding in WhizzML looks like, and then take you through a simple example of a workflow a realistic workflow that you could code in WhizzML. So we're going to have 5 parts to this talk here. In the first part, we'll just review again from the previous session what exactly is WhizzML. And then in the second part, we'll mention how you create and manipulate server-side resources with WhizzML and the sorts of resources that you can create. Then we'll kind of start to dive into the language, get into specifics, show you what code in WhizzML looks like, and some of the things you can do in WhizzML. We'll talk a little bit about the standard library of functions that we provide with WhizzML. And then finally, we'll go through a little tutorial that just tells you in a principled way how to select if you want to model your data set as a single decision tree or as a ensemble of decision trees. And so, yeah, first of all, what is WhizzML? So as was mentioned before, again, it's a domain-specific language to help you automate your machine learning workflows. And what's nice about it is that you don't kind of have to get into the nitty-gritty of machine learning. BigML is a machine learning service. We already provide all of those operations for you. The essential idea is that WhizzML is glue code so that you can construct a workflow composed of several of these resources, creating them, deleting them, parsing them, and maybe creating other resources based on the results. But you don't have to kind of dig into the nitty-gritty specifications of exactly how these resources are created. We just call the BigML API to do that, and the WhizzML code kind of nicely glues all of those API calls together, and can glue them together in an algorithmic fashion so that you kind of have all of the power of a machine learning program wrapping the calls to the API, or a programming language wrapping the calls to the API. And then also, it's scalable, and the execution can be remote. These are 2 kind of really important aspects of WhizzML. So WhizzML code, we have a local REPL that I'll show you that allows you to evaluate WhizzML programs locally. I don't know if we've made that public yet, but mostly the execution of WhizzML scripts will happen on the server side. And so what that means is you kind of get BigML's infrastructure for free. So when you say, I want to create a machine learning model from this enormous data set that normally wouldn't fit into memory on your local machine, to do that with other machine learning frameworks, you're going to have to spin up a cluster or buy a series of really high-end machines with lots and lots of memory. Here, you just write the code in WhizzML, you submit it to the server, and we execute that code for you, and you never have to worry about any of the details of how this huge data set is parsed and stored and passed around in memory and so forth. So the remote execution is a really important benefit of WhizzML. Also, you could do a lot of these things, say with our Python API bindings, but then you have this kind of client-server relationship happening where you're constantly calling the API, the results are coming back, you're doing some computation locally, maybe making another API call, and so on and so forth. With WhizzML, you're executing the whole script, all computation happens on our servers. So you basically make a single API call, and then the rest of the interaction with the API happens internally behind BigML's firewall. And then finally, it also comprises an infrastructure for sharing ML scripts and libraries. So if you do something that you think would be useful to somebody else, or even something that you think you might be able to sell, we provide you with the facilities to share those ML scripts that you've built in WhizzML for profit or otherwise. So server-side resources. So with WhizzML, BigML defines a bunch of REST resources. The basic ones are your sources, your data sets, your models, and your predictions. We also have introduced a number of other ones in the past few years, the anomaly models and logistic regression and clustering models and so on and so forth. WhizzML introduces 3 new types of resources. The first one is going to be the library. So this is if you want to provide your code as something that can be imported into another WhizzML script, the standard sort of definition of a library in the programming language world. You can say, here's a library, it provides this set of functions, and you can import this into your own WhizzML script and use that library as if you had defined the functions yourself. The second building block is a script. So a script it may import libraries, may not. And then the other 2 things unique to a script are that it takes inputs and it produces outputs. So this is an actual bit of executable code that you can define inputs and get your outputs out, and the whole execution happens on the server, and you don't have to worry about any of that again. And then finally, an execution is a resource that happens when you actually execute the script. So once you execute the script, you execute it with a particular set of input parameters, you execute it at a particular time, it spits out a particular set of log messages if you want. All of these are properties of the execution. So every time you execute a script, an execution resource is generated. Okay, so with that, I know you're all kind of champing at the bit to hear about the actual language. So here we go. Let's dive into the language. So for the basic syntax of the language, we have the kind of the usual things you might see in any programming language. You have strings that are wrapped in double quotes. You have numbers that conform to the IEEE specs for numbers, the usual sets of integer and floating point values. And then we also have Boolean values, true and false, all lowercase. Something that is a little unusual in terms of other programming languages, but you may have seen this before if you're used to programming in languages like Scheme or Lisp or Clojure, for example. We're going to use fully parenthesized prefix notation. So basically, all of your function calls will begin with an open parentheses, and then it'll be followed by the name of the function. Here we have a function called list sources, and then if there are no arguments, you'll just close parentheses, and that's what the function call looks like. If there are arguments to the function, then before your close parentheses, you will put those arguments one after the other. And then finally, these expressions can also be nested. So if you want to add 2 and 3, and then multiply the result of that by 2, any prefix notation expression can be passed as an argument into a function that accepts an argument. And of course, the function calls themselves can be nested. The arithmetic operators here, like times and plus, are not exceptions to the rule. They're just other functions. So yeah, if you just not to belabor the point here, but here I have the simple WhizzML REPL. As you can see, if I want to add 2 and 3, I just put open parentheses plus, followed by 2, followed by 3, and then it'll give me 5. And I can also do nesting expressions in the same way. So if I want to divide 10 by that sum, I can also do that. So we have variables in this language, the same as we do in most other languages. A nice thing about WhizzML is that because we're using prefix notation, we don't have to worry so hard about the set of characters that we're using for our names. So for example, we can have question marks in our names, we can have asterisks in our names. The vast majority of characters are characters that you can use in your variable names. So if we want to define a variable, if we want to bind a value to a variable, we use this keyword define. So here we're defining a variable name, and we're assigning it the value Arthur Samuel. Here we're defining another variable, birth year, and we're assigning it the value 1901. And of course, you can assign the results of expressions into variables. And so here we're assigning the result of this expression, the difference between 2016 and the birth year as someone's age. And so that the value of that expression gets bound to that variable. And again, if you're at something like the REPL, you can say define x to be 5. And then as soon as you type x, you get 5 out. So it knows that that value is bound to that variable. On literals, so there are a few important data structures in WhizzML. One important data structure is the list or a vector. And we're going to define that using square brackets and spaces to separate the items of the list that we're defining. So here we've got, at the top, we've got a list with 3 values, 1.2, 2.3, 3.4. They're all separated with spaces and wrapped in square brackets. So that'll define a list of 3 numbers. And so on, we can define a list of strings. There's nothing wrong with defining a list where the items in the list are other lists. And also you can have lists that are empty. That is not a problem either. And then also we have constructors and accessors for the items in lists. So if you don't want to use square brackets, if you want to do a more traditional function call to create your list, we have this function list. We also have a function append that takes as its 2 arguments a list and something you want to add to the end. So that'll add 4 to the end of this list, 1, 2, 3. Then the usual things in your dialects of list, you can get the first item in the list, the head. So the head of the list, 1, 2, 3 is 1. And then the tail is everything but the head. And so the tail of this list, 1, 2, 3 is 2, 3. And then finally, we have nth, which takes as its arguments a list and an index, and it returns the item at that index. So it's kind of the equivalent of subscript notation, if you want. It gets the nth item in the list that's given as the first argument. And then the other value that we can create, the other type of composite value that we can create in WhizzML that's very important is a map. If you want in Python, this is a dictionary or a hash map in Java land. Yeah, so it's basically what you're expecting it is. It's a mapping of keys to values. So here in this map, I have the key name, and I'm going to map that to the string John. I have the key married, and I'm going to map that to the Boolean value true, and I have the key date of birth, and I'm going to map that to the integer value 1901. Importantly, in WhizzML, keys in maps must be strings, which is a constraint imposed for a number of different reasons, but important to know that if you try to define a map that has a key as something other than a string, the language will be upset with you. So if we're at the REPL here and we say define x to be, here's A is 1 and B is 2. Again, we're separating these just with spaces, key value, wrapped in curly braces like this. Then it's very happy to say that A is 1 and B is 2. You can see in the output here, these are prefixed by colons, but that's just a kind of notational convenience. But if we try to define x as, say, we replace this string A and try to use the number 3 as a key, we'll get a parse error from our REPL. So that's one thing you can't do in WhizzML is use values other than strings as keys in maps. All of the maps must have string keys. And then we have some of the constructors and accessors for the maps down here. Just as a sidebar here, all values in WhizzML are immutable, and what that means is you can never once a value is created in WhizzML, it never changes. So once a map, for example, is created in WhizzML, you never change the map. You have functions that take that map as an argument and produce a new map, which is a modified version of the old map. but the map that you create always remains the same. So the constructors we have are things like assoc, this top one here, which will take a map, in this case A3, and it will append a number of keys and values to the map. Now, of course, it won't modify the map that you've already created. It will create a new map with those with the old keys as well as the new keys. So here we've got the input map A mapped to the string A mapped to the value 3, and we're going to map B to 4 and C to 5. And so out comes a new map with those keys mapped to those values. And then we also have the opposing function, dissoc, which will take an input map and demap a key from the input map, or remove a key from the input map. So in this case, we have A mapped to 3 and B mapped to C, and we want to remove B from that map, and all we're going to be left with is A mapped to 3. And then the other kind of crucial function for dealing with maps is to get the value of the value that's mapped to a specific key. So here we want to get for this map the value that's mapped to the key A, and in this case it's 1 for the input map. If you want, you can also pass in a if you pass in a key that doesn't exist, the value that you get out is false unless you use this optional argument at the end, in which case if the key doesn't exist, you get the optional argument back out. So if we're trying to find this non-existent key, normally a call to get for a non-existent key will produce false. And here, because we've used the optional argument 42, trying to get the non-existent key will yield the optional argument back out. And then there's this convenience function getIn, which will, if you have a nested map structure like this, we have A, which is mapped to a map, and that map, the inner map contains B, which is mapped to 2, and C, which is mapped to another map, which has D mapped to 42. This comes up a lot, especially in when you're dealing with WhizzML, or when you're dealing with BigML resources that get pulled down into WhizzML. A lot of times there's some deeply nested maps with deeply nested structure. So we have this function getIn, which basically will take you through the structure in a list fashion. So you have this list of keys that you want to proceed through, and you just specify them as a list, and it will follow that set of keys through the series of nestings in your input map. So in this case, the first key it looks for is A, and of course A has to be mapped to a map, and then the key in the next level inwards in the map, the next key it looks for is C, and so on. The next key it looks for is D, and so that'll pull out 42 because it'll look for A and then C and then D and pull out the value from the innermost map, 42. Okay, a few more things here about the language. It wouldn't be a programming language if you couldn't define a function. The kind of ultimate tool we have for abstracting things away and making things in our code cleaner and more encapsulated. And so here the syntax is basically the same as when you're defining a single variable, only instead of just providing a name and a value for the variable, you provide the function name, you name the arguments afterwards, that's all wrapped in parentheses, and then you provide a body for the function. So a real simple example here is we're defining this function called add numbers. It's going to take 2 arguments. In the body of the function, we'll call them x and y, and it'll just return the expression, the sum of x plus y. So there's no explicit return value. The function will just return the last statement, the value of the last statement in the function, and so the function, when called, will output the sum of the 2 numbers. Just to give you another example, here at the REPL, let's define a function called square, Q-U-A-R-E, and we'll say it takes 1 argument, x, and then the thing that function is going to do is, of course, just multiply the number by itself. And so now, and I also have to, no, that's good. And so now if I call square, SQUARE, 3, for example, I get 9. So again, you define a function, and then you can call it like you can call any other function in WhizzML. It just becomes part of your local namespace or the namespace of your script or what have you, and you can call it just like any other function. Functions are also first class in WhizzML, so we can bind them to variables. So if I have this function, here I've defined this function square, I can say define y to be the definition of that function, and then I should be able to use y. I want to make sure I'm doing this right. And then I can use y as the name of the function as well. So functions can be bound to variables just the same as values can be bound to variables. Functions are first class in WhizzML that way. So you can pass functions around as arguments. All of that is fine, and you can see examples of that in the WhizzML tutorial documentation. Here's another example of a function, and in this example, let's see where we're going. Yeah, in this example, we're using for the first functions the inbuilt WhizzML functions that will help you create resources on the BigML platform. So here we've got a function called create model and ensemble, and it takes a dataset ID, which is just the end of the URI for the dataset. We'll see more of this in a moment. And then there's these two WhizzML built-ins. One is called create model, and it takes, if any of you have used the API, you know it takes a data set as a call to create a model in the API. It takes a data set ID as a parameter, and so we're passing that parameter in as a map. And then we're also creating an ensemble, and that takes a data set ID as a parameter, and it also takes the number of models as a parameter. So here we're creating both of those in a single, we're wrapping those in a single WhizzML function. So now we can call this function once. It'll create these two resources for us, and you sort of start to get the idea of what workflows in WhizzML are going to look like. You're going to have one function that maybe wraps up a bunch of resource calls, and then maybe another function that parses those resources and does something with them, maybe creates more resources, and so on and so forth. But this is kind of exactly what WhizzML allows you to do, is create several resources in a single function call. The way we define variables with kind of limited scope in WhizzML and in other dialects of Lisp is to use this keyword let. And basically let takes a bunch of name value pairs in parentheses, and then within the scope of the let statement, anything you put in the body of the let statement, the names bound to the values bound to these names will continue to be bound in that scope. The example here, I define this variable number of models to be 10. Within this let statement, I bind these other two variables, this message I am creating, and then the ID is the ID of the data set. And then here we're going to log info, the message, and the number of models. So this is fine because we're within the body of this let statement. Then we actually create the ensemble with the given with the bound ID and the number of models defined above. And then we close out the let statement. We put the closing parenthesis on the let statement, and so anything outside the let statement after that in the code, message, the MSG variable and the ID variable are not going to be bound anymore. So the variables bound with the let statement, the binding only lasts for the duration of the let statement. We also have conditionals. What kind of programming language would it be without conditionals? Basically, you begin with the open parentheses, and then if you want to do an if statement, the next thing that comes is the condition wrapped in parentheses. So here we're using this Boolean operator greater than, and we're asking if x is greater than 0. And then the if will return a certain statement if that's true, and a certain statement if that's not true. When is similar, except it doesn't contain an explicit return value if the condition isn't true. So if the condition isn't true, we just end up returning false. But the statements within the when only exist when the condition is true. Only execute when the condition is true. We have a special form of conditional statement called cond. If you find yourself doing nested conditionals here, if x is greater than 3, we're going to say this is big. Otherwise, if x is less than 1, we're going to say it's small. And then if neither of those conditions is met is standard. With cond, we can kind of make that a little more clean, where we just say, okay, here's the first predicate, and then if that evaluates to true, then we're going to return this. And then it just takes a list of these things. So it's a little bit like a beefed up version of a switch statement in other languages. Basically, you get a condition, and then if that evaluates to true, you do X. If the next thing down evaluates to true, you do Y. If the next thing down evaluates to true, you do Z, until you get to the bottom, and then you have a default return value if none of those things, if none of the predicates in the cond execute to true. We have exceptions, as we do in any other language. So we raise an exception with the keyword raise. You can raise any value in WhizzML, but the kind of standard convention is to raise a map. Importantly, with the key message, because that's the message that will print when the error propagates up to the top level. And you can also raise a code. We have several standard codes, but you can make a code for anything you want for your own purposes. And then since we can raise errors, we can also do try and catch on those errors. So we can try the body of a statement. The body of the try happens right after the initial keyword there. And then after the body, we specify that we want to catch the exception. We're going to call it E in the body of the catch statement. And here we're just logging the message and code that comes out of the exception that we've just caught. So in this case, obviously, this code might be prone to exception because x could be 0, and in that case, we'll get a divide by 0 exception. So this catch block, if x is 0, will fire and will print those messages off. So here's a really just kind of trivial script that doesn't do much, but it demonstrates the capabilities of the language. We're going to define a function or we're going to define a little script here that creates a data set and then returns the number of rows in that data set. And so first we define this function, make data set. It takes the ID of the source that we want to make the data set on, and it also takes the name for the data set. And then this function is basically just a wrapper for this API call to create and wait data set. And what create and wait data set is one of the built-in WhizzML functions. And what that function does is it makes an API call to create a data set, and it blocks until that API call is finished, until the resource either goes into an error state or signals that it's complete. And so we do that, create and wait data set. We capture the data set ID. We bind it to this variable using let. And then after it's, like I said, this blocks until the creation of the data set is finished. And then afterwards, we're going to fetch this data set from the server. So if any of you have dealt with the API, you know that the thing that comes out when you fetch a resource from the server is a bunch of metadata about that resource. And so here we're going to define the data set to be the evaluation of this function call. And what that means is that we're going to make the data set. We're going to do the steps up here. We'll make the data set, block until it's finished, and then fetch the metadata associated with that data set. And then we're going to bind it to this variable data set. And then here, we're getting the data set, getting the value bound to the key resource from that data set metadata. And then here we're also getting the value bound to the variable, or bound to the key rows in that data set. So finally, we get the rows out, and that's the number of rows in the data set. So a pretty simple script. We make the data set, we retrieve the metadata, and then we kind of dig through the keys in the metadata to get the values out that we want. And if you want to play with this script, there's a gist on GitHub that will allow you to download and execute the script yourself. So the next thing we're going to talk about is the standard library. So what are the functions that are available to you? We kind of went over the syntax, how to call functions in WhizzML, how to define your own functions, but what are the functions that we provide for you? It's pretty generous at this point. There's quite a few functions. All of the usual numeric and relational operators are there. All of the binary operators you're used to, or the things you normally use in conditionals, less than, greater than, equal to, et cetera, et cetera. We have a bunch of math functions, the trig functions, transcendental functions, things like ceiling and floor and round. So all of the usual numerical operators. We have strings and string manipulation, so you can get substrings and certain letters in a string. And you can also do regular expressions in the usual ways. So we have functions like matches and replace that take regular expressions as arguments. Flatline, if you've never used Flatline, I encourage you to do so. It's our DSL for dataset transformation, and Flatline is a first-class citizen in WhizzML, so you can create Flatline expressions to modify your datasets or to create new fields in your datasets from WhizzML. And then we have the usual things that allow you to manipulate collections, so list traversal, things like performing doing a map, so performing a function on every element of a list, sorting lists, sorting by getting sublists, and so on and so forth. And then finally, kind of the money, the payoff, is BigML resource manipulation. So for any resource that you can create with the API, there's a corresponding WhizzML function that allows you to do it in a single function call in WhizzML. So there's things like create source, create dataset, create batch centroid, create clustering, and so on and so forth. You can create any of those resource types in WhizzML with a single function call. And then also there's these blocking calls that I mentioned before, create and wait for dataset, source, model, ensemble. Again, for any resource type, you can create and wait that type of resource, and that'll create the resource and block in the WhizzML script until creation is complete. There's a few functions for retrieval. The main one is fetch, which allows you to pull down the resource metadata in the same way you would in the API. And then there's a few other ones. List anomalies is specific to anomaly detection, and so on and so forth. The resources that you're able to update, you can call update and pass new parameters or set new parameters in those resources. And finally, you can delete resources from WhizzML as well. And then also in WhizzML, we have a number of machine learning algorithms, meta algorithms that we've already implemented in WhizzML, and that we provide as examples in libraries and so on and so forth. And those I'll be talking a little bit more about tomorrow, I believe. Okay, so at the end of that, the sort of fire hose of information about WhizzML, we'll take you through a little tutorial walkthrough here. And this, again, I mentioned this at the top. This example basically is we're going to choose in a principled way whether or not we want to grow a single decision tree or a ensemble of decision trees to do predictive modeling on our data. So there may be a variety of reasons you would rather use a single tree than an ensemble of trees. It's a little faster, it's cheaper, it's a little more interpretable, for example. So you may decide if you're not getting any additional performance by using an ensemble, that you would like to use an individual tree. And this little WhizzML script will answer that question for you. Am I getting any performance bump from using a bunch of trees rather than just a single tree? So at a really high level, it's a pretty simple set of operations, but one that would take maybe, somewhere between 5 and 10 API calls to accomplish. So something that, if you do it a lot, is probably worth automating, especially in the UI. This is something that's going to take a lot of clicks and will take at least minutes to execute manually from the UI. From the UI is where it has a big benefit. So that in that case, if you're using the UI to do this, it definitely might be worth automating, worth grouping into a single script. So what are we going to do? We're going to split our training data set and our test data set or we're going to split our single data set into two parts, one for training and one for test. And then we're going to create a model on the training data set, and we're also going to create an ensemble on the training data set. So we have two separate models of the data, and then we're going to evaluate both against the test set. And that's going to be our measure. That's going to be the way we decide whether or not one is significantly better than the other. And then we're going to choose from our two evaluations, the one of the model, the one of the single model, and the one of the ensemble. We're going to choose the one where the evaluation is better. And we're going to say an evaluation is better in this case by using the F measure, which is one of the measures we provide you with when you do an evaluation. And you can see in the URL here, you're able to clone this and run it yourself just by using this URL here. Okay, so as I mentioned before, the first thing we have to do is split our data set into training and test sets. And so we have a couple of functions here that allow us to do that. The first two functions here. We're going to define this one called sample data set. And it's going to take 3 arguments. The data set ID that we want to split, the rate, which is going to be the amount that we want to split off. So if you want an 80-20 split, you could say 80 here. If you wanted a 50-50 split, you'd say 0.5. I'm sorry, you would never say 80. You would say 0.8 if you wanted an 80-20 split. If you wanted a 50-50 split, you'd say 0.5, and so on and so forth. And then this parameter, this Boolean parameter, OOB, stands for out of bag. So basically, this makes sure that the subsets, when we split off our data set into 2 subsets, that we do it in a way that's disjoint, so that you never see any examples in training as you do in test. So you don't get so you don't get to cheat and look at your test examples during training. And so basically, this is just a wrapper for create and weight data set. And it's going to sample at the rate that we provide. So if we provide a 0.5 here, it's going to take half of the input data set. Here's the input data set ID that's going to get mapped to origin data set. And the outer bag parameter, OOB, is going to get mapped this way. Notice that create and weight data set takes a single argument, this map, and the keys in this map correspond exactly to the arguments that you would pass into to an API call to create the same thing. So if you want to know what keys are available here for create and weight data set, you can always go to the API documentation that will the same set of keys applies. And then finally, we're going to specify a seed just to make sure this whole thing is repeatable and we don't get burned by random number generation. Yeah, so once we have this function, which will create a single sampled data set from our input data set, we can define a function called split data set, which just calls this function sample data set twice, once with the out of bag parameter as false and the other with the out of bag parameter as true. And what that means is that if you specify a rate of, say, 0.8, you want an 80-20 split, you get 80% of the examples in the first data set, and then in the second data set, you get the remaining 20%. you get everything that you didn't get in the first data set. So that's the point of this out of bag parameter, is to have this disjoint split where you can make sure that examples, training examples from that data set only end up in one data set or the other, but not both. So now we've split our data set into two data sets, one for training and one for testing. And as I mentioned, we're going to make a model and we're going to make an ensemble out of that data. And so we have these two wrappers, make model and make ensemble, which are basically just wrappers around the create and wait model and create and wait ensemble functions. So again, those functions are just going to make an API call and block until the resource completes creation. And then we can do the same thing here for evaluations. We have a function evaluate model, which is just a wrapper for create and wait evaluation, and it'll evaluate the model that we created in the last step. And similarly, evaluate ensemble is just a wrapper for create and wait evaluation, and instead we're passing the ensemble in as the thing we're going to evaluate. And then the last little piece here is define something that will take an ID from an evaluation and just get out the F measure, because that will allow us to compute which evaluation ends up being better. And all this function is it calls get in, and it kind of scans through the metadata that comes out of the evaluation. So it goes into the result map, into the model map, and then gets out this key average F measure, which contains the value that we want. And then finally, we put it all together. This is the kind of main entry point for the function. First we'll create and wait a data set from a given source ID from the source that we pass in, and so that's the full data set. Then we call that function split data set. We pass in 0.8 here, so we get an 80-20 split. And if you remember back when we defined split data set, it returns a list of the two data sets, the in-bag samples and the out-of-bag samples. And so then when we go to call it here, this IDs gives us a list of two IDs, the in-bag data set and the out-of-bag data set. And so we'll use nth to grab the 0th ID in that list and assign that to this variable train ID. So that'll be our training data set. And similarly, for the first, all lists in WhizzML are 0 index, so this is the second element in the list. We'll assign that to be our testing data set. So now we've got our training and testing data sets. We'll make a model on our training data set. We'll make an ensemble on our training data set. And then we'll evaluate model and evaluate ensemble. And the metadata that comes out, the evaluation, or rather the resource ID that comes out, the evaluation IDs for either of these things, we'll use that function F measure to pull in the metadata from each of those evaluations and pull out the value that we're going to compare, which is the F measure. And so this is going to be the F measure for the evaluation corresponding to the model, and this is going to be the F measure for the evaluation corresponding to the ensemble. Then just we'll print out a little message, log info, which will tell us, which will show on screen that this was the evaluation of the model that we created. This was the evaluation of the ensemble that we created. And then finally, this last conditional says if the model F measure was greater, then we're going to return the model ID, else we're going to return the ensemble ID. So it'll just choose whichever one is better, and that's the ID it's going to return for you. So again, what's nice about this is that if we go over here to a web browser, I already have this. This is our GitHub repo of WhizzML examples. We already have model or ensemble right here. And so one of the nice things I can do is, since this is already written for me, here's the script itself. It just contains exactly the text that we've been going over in the example. So I can just copy this directory wholesale, and I can say I want to import a new script from GitHub in my in the UI, in the BigML UI here. and I can paste that URL into my web browser, and the web browser parses the code. It knows what the inputs and outputs are because we've defined this last line at the bottom. We've defined a variable that calls our main entry point, and so it knows that we're going to specify this as the input, this is the output, and so it's pretty simple just to import this once someone has written it, import it into the BigML UI, and now instead of having to do this with many clicks, having to create a source or rather create a data set, split the data set, create model, create ensemble, create the evaluations from the two, and then look at each one and compare, we can just select a single source here and execute the script. So again, this is kind of the main benefit here is that you can automate the creation of these resources. That's how many resources is that? That's a data set, and then the two split data sets, and then the model ensemble, the evaluation. So it's at least 8 resources. In this case, here you can see the result. It's decided that the ensemble is the superior model. And if we look in the console here, we can see that it's logged the F measure when we called that log info function. It logged something to our console here. The F measure of the model was 0.7. The F measure of the ensemble was 0.74. So we did indeed get a little bump from using several trees rather than just one. Yeah. So again, like rather than having to click around the UI and do all this stuff manually or make a bunch of API calls, we can encapsulate this in a single WhizzML script and execute it from the UI in basically a single click, and create all those resources and get all the information that we otherwise would have had to do a lot more clicking to find.